Hello, this is Mathematics for Combination, Unit 9, Random Variables, lesson number 2. Binomial distribution or law of Bernoulli and Poisson distribution, presented by Tutor Louis Tresford Munyemana. Binomial distribution or law of Bernoulli as definition: let x be the random variable, the number of success in the n trio. Let p and q be the probability of success and failure in any one trio. P present probability of success, q present probability of failure. Here is when you take example of tossing a coin. When head is up, is success. When tail is up, then we consider tail as a failure. In the n independent trios, the probability that there will be R success and n negative R fails is given by probability of x equal to R. R is the number of success, trio successes, which is equal to combination of R in n of probability of success per R times the probability of failure per n negative R, when R is equal to 1, 0, 1, 2 till n. The probability distribution of the random variable x is therefore given by, this is table of probability distribution from 1 to n. Then probability represented by combination of 0 to n, probability of success per 0, probability of failure per n till where you have n to n, probability of success per n times probability of failure per 0. The probability distribution is called the binomial distribution because for R equal to 0, 1, 2 till n, Px are the probability of successive terms of the binomial. Expansion of probability of success plus probability of failure per n. Binomial distribution was discovered by James Bernoulli in 1700 and is denoted by B factor of R the point n and p, means is based on probability of success, which is equal to combination of R in n times probability of success per R times probability of failure per n negative R. This R on combination must be equal to the same R on power of success. Then R is from 0 to n. The constant n, p and q are called the parameters of the binomial distribution. Noted that when we take probability of success plus probability of failure, always must be equal to 1. For n is number of set. Then a small n here is trio, number of trio. The success from 0 to R and then to n are given by capital N factor of probability of success plus probability of failure per n, which is called the binomial distribution. This one is called binomial distribution. We have an example here. During a war, a ship out of 9 was sunk on an average in making a voyage. What was the probability that exactly 3 out of a convoy of 6 ships would arrive safety? The probability of success P represent the number of chip arriving safety. Otherwise, P is equal to 1 negative 1 over 9, means the probability of success is equal to 8 over 9. Probability of ship which sank is equal to 1 over 9, means probability of failure is equal to 1 over 9. Number of trio is equal to 6, number of set of ships is equal to 1. The binomial distribution can be represented or written as here you see is n factor of probability of success plus probability of failure power n. This one will give 1 power 6, which is equal to 1. The probability that exactly 3 ships arrive safety is, it is a combination of 3 out of 6. 3 out of 6 times the probability of success power 3. 3 must be equal to this one times the probability of failure, which is equal to 1 over 9 power 3. When we make this combination, it gives 20 times the 512 over 9 power 6. This one will give 0.0193. We have example number 7. The probability that a person belongs to a certain club A is 0.6. To be in club A, probability is equal to 0.6. Find the probability that in a randomly selected sample of 80 people, there are exactly 3 people who belongs to club A. B, more than 5 people, more than can be more than 5 people who belongs to club A. In this case, success is belonging to club A and failure not belonging to club A. You know, to be in club A, probability equal to 0.6, means probability of success. To not belong to club A is equal to negative 0.6, is equal to 0.4. Number of 3 is equal to 8. Number of set is equal to 1. So the binomial distribution is written as n times p plus q per n, which is equal to, here you have sign of plus 0.6 plus 0.4 per 8. Third, probability of get to be exactly in club 3 is equal to 3 out of 8 probability of success plus 3 times probability of failure power 5. When you make substitution of each value, we get 0.12 per 4. Probability of more than 5, it is all values to be in a group which is more than 5. It is greater than 5 group. To be in more than 5, x can be equal to 6, x can be equal to 7, and x can be equal to 8. We take probability for the case of x equal to 6, which is equal to this one. Probability of x equal to 7 is equal to this one, and the probability when x is equal to 8 is equal to as here you see. Then when we make a sum operation, we get probability of 0.316. The probability that a pen, example number 8, the probability that a pen draw at a random from a box of pens is defective is 0.1. To be defective of pen, when you draw a pen, for example in a box, to take a pen which is defective is 0.1. If a sample of 6 pens is taken, find the probability that if will contain no defective pen, 5 or 6 defective pen, less than 3 defective pen. Here the probability of success is to check, is to choose a defective pen. Failure is to choose no defective pen. Is the reason why probability of choosing defective, which is success probability, is equal to 0.1. Probability of failure is equal to negative 0.1 is equal to 0.9. With n is equal to 6, number of trio is equal to 6. Probability of getting no defective pen is equal to 0 out of 6 times 0.1. Probability of success power 0 times the probability of failure of 0.9 power 6, which is equal to 0.531. Then probability of getting more than 4 is equal to probability of 5 plus probability of 6. We make operation for the case of probability when x is equal to 5. It is 5 out of 6 plus 6 out of 6. This probability will be equal to 0.00055. Then when you have a probability which is less than 2-3, it is less than 3 defective pen, means less than can be 0, can be 1, can be 2 defective pen. Is the reason why here you have or probability which is less than 2-3 can be probability of 2 of getting 2 defective pen, of getting 1 defective pen, and of getting 0 defective pen. When you make a property and a formula of Bernoulli, we will get 2 out of 6, 1 out of 6, 0 and out of 6. When you make operation, the result will be equal to 0.98 as the probability of getting more than 3 defective pen. The following data shows example number 9. The following data shows the number of seeds germinating out of 10 on no damp filter. For 8 set of seed fit a binomial distribution for this data. We have to do a binomial distribution for this data. We have a value of x, this f is the value of frequencies. We calculate the value of mean x is equal to sum of x times the frequency over sum of frequency. To find the mean, we have to make operation multiplication of x times the f. 0 times 6 is equal to 0, 1 times 20 is equal to 20, and so on until 10 times 0 is equal to 0. Then when we make a sum of x times f is equal to 174. Then when we make substitution, the sum of frequency is equal to 80. You get 87 over 40. The mean of binomial distribution here can be written as mean mu is equal to n times p, number of trio times the probability of success. Given that n is the number is 10 trio, we have a t set and we have mean of 87 over 40. To find the value of probability of success, for this relation you can remove the value of p. Then you know n is equal to 10. It is like to take n, you divide it on 87, then it is 87 over 10 times 40, which is equal to 400. When you make this operation, it is equal to 0.2175. Probability of failure is equal to 1 negative p, which is equal to 0.7825. A binomial distribution here it is make the substitution of this relation of binomial distribution. N is equal to 80. Probability of success is equal to this one. Probability of failure is equal to, when we make power 10, then we somehow get the value of binomial distribution. First, expected frequency is here. How is it find? This is expected frequency. Expected frequency this is expected frequency. Expected frequency is equal to multiplication of number of set capital N times the probability distribution. Here you have capital X, which is equal to small x, where the probability of here probability distribution formula from Bernoulli can be written as we have a combination of R in N trio, then times the probability of success for R times probability of failure for N negative R. So is the reason why to find a 6.9 is first of all to calculate probability distribution for this case. Means we have to find for the first case when you have 0 is 0 out of 10 times the probability of success. You know probability of success is this value. You take 0.2175 power R is 0. For this case, R is 1. For this case, R is 2. For this case, R is 3. For this case, then times the probability of failure. You know, probability of failure is equal to 0.7825 per N. N is equal to 10. You take 10, you subtract the value of R. For the case 1, R is equal to 0. Second one is 1, and third. Then, after getting the value of this probability, for the case 1 you multiply 80, second case you multiply 80, you know a value of N is equal to 80, and so on. This is why you get this table of distribution frequency. We have a case of expected value. Expected value, variance, and standard deviation of binomial distribution. For this case, expected value or mean of binomial distribution of a discrete random variable x is denoted and defined as mu is equal to e of x, or expected value is equal to a number of trio times the probability of success, where N is the number of trios and P is the probability of success. The variance of a binomial distribution of discrete random variable for this case of Bernoulli is equal to n times probability of success times probability of failure, or you can write the probability of failure in function of probability of success, when probability of failure is equal to 1 negative probability of success, where n is the number of trials, p is the probability of success, and q is the probability of failure. The standard deviation here of binomial distribution is square root of variance, when variance is equal to n times the probability of probability of success times probability of failure. Example number 10. A die is tossed thrice. If getting an even number is considered as success, what is the variance of the binomial distribution? You know, to get even number, a dice has 6 sides from 1 to 6. You know, even number is equal to 2, 4, and 6. You know, probability of getting each value is equal to 1 over 6. Probability of getting 1 up is 1 over 6. Probability of getting 2 is 1 over 6. Probability of getting 3 is 1 over 6. Still, probability of getting 6 is also 1 over 6. Then you have 3 values, 2, 4, and 6 is the reason why we have 3 out of 6. Probability of getting even number is equal to 1 over 6. Probability of getting other number is like odd number is equal to probability of failure is equal to 1 negative 1 over 2, which is equal to 1 also 1 over 2. Number of 3 is equal to 3. Then the variance of binomial distribution here, it is very simple. Is to take the number of trio times the probability of success times the probability of failure, which is equal to 3 times 1 over 2 times 1 over 2 equal to 3 out of 4. It's very simple. Example number 11. The mean and variance of a binomial distribution are 4 and 3 respectively. Mean and variance. Mean is equal to 4, variance is equal to 3. Find the probability of getting exactly 6 success in this distribution. We know two relation. Mean is equal to n times p equal to 4. Variance is equal to n times p times q equal to 3. When we take these two relation, we can find the probability of success and the probability of failure. From this relation, you know the value of you have n times p times q is equal to 3. Then 4 times p, the value of n times p, this one is equal to 4, as here you see. It's the reason why we take 4 times p, which is equal to 3. The value of probability of failure is equal to 3 out of 4. When we found probability of failure, this means probability of success is equal to 1 negative probability of failure. Means 1 negative 3 over 4 is equal to 1 over 4. From the relation 1, n times p is equal to 4. What is the value of n? Can calculate n from this relation. N is equal to 16, 4 times 4. The probability of getting 6 success, we have to apply this relation. 6 out of 16 times the probability of success power 6 times probability of failure power 10. When we make this relation, we will somehow find exact numbers. It's also very easy. We have example number 12. In a 256 set of 12 tosses of a coin, how many cases one can expect 8 head and 4 tails? out of 12. Then let P be the probability of head and Q probability of tail. To find the head is success. To find the tail is fail. Means probability of getting a head is equal to 1 over 2. Probability of getting a tail is equal to 1 over 2. Then n is equal to 12. Capital N number of sets is equal to 256. The binomial distribution can be written as here. You see, we have to make substitution only. The probability of 8 head and 4 tail is in the 12 trio is given as 8 combination of 8 in 12. Probability of success is 1 over 2 power 8. 80 success. Then probability of failure 1 over 2 is 4 fail is equal to 495 over 496. The expected number of such a case in this set 256 sets, we take this probability as P times A, which is equal to expected value is equal to 30.9, approximation of 31. Example number 13. A random sample is taken on 800 families with 4 children. Each how many families would be expected to have 2 boys and 2 girls, at least 1 boys, no girls, at most 2 girls. At least is greater than at least is sum of 2. At least here 1 boy means can be 1 boy, can be 2 boys, can be 3 boys, and so on. At most 2 girls means 2 guys is a greater number. Can be 2, can be 1, and it can be 0, assuming equal probability for all boys and girls. Since the probability for boy and girl are equal, let P be the probability of having a boy and Q be the probability of having a girl. Probability of having of success of having a boy is equal to probability of not having a girl, means having a girl is equal to 1 over 2. Number of 3 is equal to 4. Number of set is equal to 800. The binomial distribution is n factor of probability of success plus probability of failure per n, which is equal to this one. Even you put similar plus. The expected number of family having 2 boys and 2 girls, expected number is, we take 8 times the probability of having 2 boys and 2 girls. This is expected number, expected number of families. Then we take capital N, we multiply probability of having 2 boys and 2 girls, which is equal to this one. The number of family, 300 families will have at least 2 boys and 2 girls. The expected number of families having at least 1 boys is, at least 1 boys means can have 1 boys, have 2 boys, can have 3 boys, can have 4 boys. As we have 4 sample of 4. The reason why we take all multiplication of probability and then we multiply 80, we get families, 750 families who have at least 1 boy. The expected number of families having no girls means it is no girls. You will get 80 times the probability of having four boys. Means when you have 4 boys, means there is no girl in the family, because we consider 4 child in one family. When we have 4 boys, we will consider that there is no girl. It's the reason why we use this property, and then have 50 families are not to have girl. Last sub question. The expected number of families having at most 2 girls is, at most can be no girls, can be 1 girl, and can be 2 girls. We will take probability of having no girl, probability of having 1, and probability of having 2 girls, and then we will get the family of families having at least 2 girls is equal to 550 families. We take another point: uncountable infinite discrete case or Poisson distribution. The Poisson distribution here as definition is a discrete distribution, or often used as a model for the number of events, such as the number of customers in a waiting line, number of defects in a given surface area, airplane arrival, or the number of accidents at an interaction in a specific time period. A Poisson distribution is a limiting form of the binomial distribution, as here you see, limiting. Then when a binomial distribution arrives, Poisson distribution continue. For this case, when n approaches to infinite, means we will use Poisson distribution. We can't use binomial distribution, because n is the number of trio is high, is very high, up to infinite, means it is very big. Then when a number of trio is very big, we will use Poisson distribution. Probability can be when p approaches to 0, means it is very small. Probability of success for the case of Poisson distribution is approaching to 0, is near to 0. So for this case, and this, in place of using a binomial distribution, we will use Poisson distribution. The constant probability of success for each trio is infinitely smaller. N times p is a finite quantity, say lambda, means lambda is mean. As binomial distribution, lambda here symbolizes mean is equal to n times p, as it is in the case of Bernoulli. So probability here of success is equal to lambda, or mean, over n. Probability of failure is equal to negative probability of success, where r is positive real number. The major differences between the Poisson and the binomial distribution is that the Poisson distribution does not have a fixed number. Poisson distribution does not have a fixed number, can have infinite numbers of trio. But if instead they use a fixed number of time or space in which the number of success is recorded, typically event which could have Poisson distribution are this case. Then, when we consider number of customers arriving at a supermarket checkout per minute, this one we will use Poisson distribution. Number of suicides or death caused by heart attack in 1 minute, consider per time period. This one also will consider Poisson distribution. The number of accidents that take place on a bus on a busy road in time t, this one also will use Poisson distribution because those one are according to time period. Number of printing mistakes at each unit of the book, also this one will use Poisson distribution. The number of cars passing a certain street in time. The number of persons born blind per year in a certain village, and so on. Those are cases where we use the Poisson distribution. The probability density function of Poisson distribution, we will use this formula. Probability of x equal to small x is equal to e, Neperian number, power negative lambda. You know lambda is equal to mean, is considered as a mean, positive number. Then lambda power x over x is value from 0 to n number over factorial of x, where x is parameter which indicate the average number, the expected value, the event, the given time interval, and the pair number can be written equal to approximation of 2.718. The Poisson distribution is written as capital X approximate to P0 of lambda, means average number. If the initial probability is known, you can find the successive probability using the following formula. You know initial probability, for example for x, then you can calculate x plus 1, x plus 2, x plus 3, and so on. Then finally, by using this relation, you replace x by x plus 1 and so on. We take this one, we make a proof. Finally, the principal formula essentially is somehow this relation of getting, when you have previous relation, we can find the successive or the following relation or probability by using this relation. For Poisson distribution of a discrete random variable x, then the mean mu or expected value and the variance square, which is this is symbolizes variance, are the same and equal to lambda. Means mean or expected value and the variance is equal to lambda. Those are equal, or mean and the variance are equal to lambda. We have example 14. On average, on Friday, a waitress get no tips from 5 customers. Find the probability that she will get no tip from 7 customers this Friday. We know 5 customers on average. 5 customers on average means lambda is equal to 5. The value x is the number of customers. When we apply our probability on the case of x equal to 7, we get the probability that she will get no tip from 7 customers is equal to p of x equal to 7. When we apply probability for the case of Poisson, e power lambda negative lambda times you know lambda is equal to 5 power x is equal to 7 over factorial of 7. This one is equal to 0.104. Example 15. A small life insurance company has determined that on the average, means on the average is the value for lambda. When you understand on the average symbolize lambda, is receives 6 death claims per day. Find the probability that the company receives at least 7 death claims on a random selected day. company received at least means 7 is smaller than the remaining. It is from 7 to infinite. Since lambda is equal to our average is equal to 6, then we take probability of x more than 7. It is greater than x greater than 7. The probability of x greater than 7 is like to take probability of one negative probability of all numbers greater than or all numbers less than 2, 6. Also 6 is belong. So we will take the probability of x greater than or equal to 7 when we take one negative probability of all values of x less than or equal to 6. Is the reason why probability of x less than 2, 6. It is from 0 plus probability of x equal to 1, equal to 2, equal to 3, equal to 4, equal to 5, and equal to 6. We will calculate the probability of this value, and then by making substitution in the formula of Poisson distribution, we will get 0.626 and 5. Of getting probability of getting at least 7, we take one negative probability. Find in this case of 0.6265, which is equal to 0.3735, and then the answer is this one. Example number 16. The number of traffic accidents that occur on a particular stretch of road during a month follows a Poisson distribution with a mean of 7.4 or 9.4. Find the probability that less than 2 accidents will occur on this stretch of road during a random selected month. You know, the mean lambda is given is equal to 9.4. We need to find the probability which is less than 2. 2 means is from 0 to 1. 0 and 1 means we state or we count from 0, 1, 2, 3, 4. Then when we calculate probability of the value less than 2, 2 is like to write probability of x equal to 2 plus probability of x equal to 1. When we apply formula of probability of Poisson distribution, it is equal to this one plus this one is equal to 0.00085. Example 16. If the variance of the Poisson distribution is 2, find the probability for x equal to 1, equal to 2, equal to 3, and equal to 4 from the recurrence relation of Poisson distribution. Also obtained from this relation x, probability p, x is greater than or equal to 4. We know Poisson distribution, mean and variance are both equal. Means mean is equal to variance and equal to 2. Recurrence relationship Poisson distribution, as you have seen it above, is equal to x plus 1. X equal to x plus 1 is equal to lambda over x plus 1 times the probability of x, which is equal to probability of x plus 1. When we make substitution of lambda is equal to 2 over x plus 1 p of x. The Poisson distribution is, as here you have a relation of Poisson distribution formula. We start from x equal to 1, equal to 0, equal to 1, equal to 2, and equal to 3. Then we are asked to find the probability which when x is greater than or equal to 4. For the case when x equal to 0, p1, when we make a substitution here, p0, we make substitution here 0. It is p of 1. We replace 0 here is p of 0. When we make substitution is p0 will be written 0 here, and then make substitution this relation we replace here in the place of 0. When we replace 0 in the value of here 0, we put 0 here 0. Lambda, the value of lambda is known is 2, and 2 we will find the value of 0.1353. When we make multiplication, we get this result. For the case of x equal to 1, take 1 here, replace it here. 1 plus 1 is equal to 2. It is p of 2. 2 here, 1. You get 1 or 2 over 2. Probability of 1 will also make substitution of, in this relation, probability p of 1. P of 1 is given. Can be found from this relation. This is p of 1. You can take this value and then make substitution here. You get 1 over 2 over 2 is equal to 1. 2 over 2 is equal to 1. When we make this value, it's the same as here. You see the reason why you get the same value, and so on. In the case of x equal to 2, it's done as here. You see, we make p2, we replace it by p3. This p2 is replaced by this one. This p3 is replaced by this one. Finally, we make probability when x is greater than 4. It is p equal to 4 plus p equal to 5 plus p equal to 6 till to infinite. You know, it's very, we can't count the number of x, of those values. The reason why we get the smallest one from 0, 1, 2, 3, and then we make subtraction to 1, we'll get this value, because a sum of all probability is equal to 1. It's the reason why we take 1, we subtract the value which is less than 2, 4. Then this value are found from this one, this, and this. We make substitution. Finally, final answer is equal to 0.1431. So this is the end.